Hi, we introduce the PhD qualifying exam in Université de Montréal. There are two writing exams. First exam, you see, this is simple. The subjects in the first exam include linear algebra, analysis, complex analysis, Fourier analysis, differential equations, and some basic abstract algebra, and general logic, differential geometry, and probability. The second example is special for the students majoring. For example, there is a sample of the example for algebra. The major reference book is that abstract algebra by Dumit and Foote. Example include for groups, rings, modulus, field series, Galois series, homologic algebra, two homologic groups, commutative algebra, representation of finite groups, and something Lie groups, etc. Okay. Now we give an example in Université de Montréal in the year 2016. UDM is a French-speaking school. Here I translate French into English. This is the English version. Let G be a bounded and increasing function over the open bounded interval A with A smaller than B. 1. Prove that G A plus and G B minus exist and are finite. 2. Prove that G is continuous if and only if G is uniformly continuous. Proof. Since G is bounded in A, B, there are M in a set of real number such that M small or equals Gx and Gx small or equals bigger M for any x in the open interval A, B. Now define Ga equals small m, Gb equals bigger M. Then G is defined in the closed interval AB such that Ga equals or smaller than Gx and Gx equals smaller than Gb for any x in the closed interval A, B. Now, let C in A, B. C could equal to A. Since G is increasing in AB, the set the x in open interval AB. In fact, open interval C infinity is bounded below by BC. where GC in this interval C to B, Gx bigger than GC. So the greatest Roy bond, this one exists. Now let alpha be this greatest Roy bond. Then we see smaller or equals alpha, since alpha is the greatest Roy bond. And the GC is just a Roy bond. Let strong bigger than 0. Since alpha is the greatest Roy bond, there is x0, an interval AB intersects interval C infinity, such that alpha smaller than or equals gx0. Gx0 smaller than alpha plus epsilon. Let beta equals x0 minus C. So x0 equals beta plus C. Then for any x in the open interval AB such that C smaller than x smaller than C plus delta equals 0. Since G is monotone increasing, alpha smaller or equals Gx. Gx smaller equals 0. Gx0 smaller than alpha plus epsilon. This means absolute value x minus alpha smaller than epsilon. This means for any epsilon bigger than 0, there is a data such that if x is in this interval, then the absolute value x minus alpha smaller than epsilon. This is the definition of the limit. This implies C plus exists and G C plus equals alpha. Alpha is another one. Now that C is in A, B, like that. So C could be A. That gives the A plus exists. And the A plus equals this greatest Roy bond. Similarly, we can prove by letting B in A, B. We can prove B minus exists. And B minus equals superior this one. Now, question 2. If G is uniformly continuous over AB, then G is continuous in the AB. This is very clear. Now, suppose that G is continuous on the open interval A, B. I1, we can define A equals GA plus and GB equals GB plus. Then B is continuous on the closed interval A, B with the interval is bounded. Thus, B is uniformly continuous on the closed interval A, B. This completes the proof. Sorry, this should be B minus, not B plus. Thanks for watching. Bye.